Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome again to another episode of the Smart City Podcast.
Today, I'm very pleased to be joined by Peter Harding, founder and CEO of Kelvin.ai. Welcome, Peter. How are you this morning?
I'm doing well, Jim. How are you?
Super. Thanks for being a guest today. To get started, let me just ask you, how did you come to this ecosystem in this space? Tell us a little bit about yourself and how you got here.
Yeah, so I'm a Bay Area kid, born and raised in the Silicon Valley. My father was an entrepreneur. My grandfather was actually an early developer of radar technology. And what I found was there were huge opportunities out there to use some really interesting new technologies to have a very positive impact in terms of global warming, sustainability, and just the overall production opportunities that exist. And rather than continuing down a path where I had taken, which was focused more on finance, I wanted to figure out how could I use a lot of these interesting new software, IoT, and really sort of AI tools to be able to solve some of the more complicated and potentially incredibly impactful challenges that we were addressing today. So that's how I got into this.
Tell us a little bit about AI and the general ecosystem. There's a range of perspectives from the old Terminator movies to there's a lot of different assumptions. It's very broad. So what is AI in an industrial perspective?
I look at it as, first, AI as an incredible tool for finding patterns. And when I think about what a lot of our users do, which is they're engineers and operators who are looking to find patterns in their day-to-day, an understanding of how that operation is acting. And then when there's a change in a pattern, usually that means there's a change in the state of whatever that system is that they're responsible for. And I actually think AI, in terms of the pattern matching capability, is a very powerful tool in terms of that first phase of discovery. The next part of it is it also provides an opportunity to make lots of small incremental changes that in a system that can then be measured and learned from. And so rather than when we think about turning a valve, from 0 to 10 and back to 0, you're going to get some very significant changes in that system potentially downstream. There's a way to do that on a more incremental basis as well, and see if we turn it up by 1 and then down by 1, what do we see? And that's the next piece where I think that there's a lot of opportunity for iteration and for learning, and where I see there being some really interesting stuff. The last piece is fairly new as we look at many of the things that I think of late we've seen from more of a generative AI. I know that there's a lot of focus around ChatGPT and the OpenAI initiatives from Sam Altman. And what's interesting about that is it's really a change in the interface by which we capture the understanding that maybe an engineer or an operator has and transition that into some sort of code. And what I think is super powerful about this concept is there's been a lot of focus in the last 5 to 10 years on how do we simplify understanding and ways to describe a system. People will talk about no code and low code. These are sort of very popular initiatives right now. The thing about what we see with ChatGPT is potentially the fact that you may not need many of those tools anymore. If people can describe what it is that they're looking for in plain English, there's an opportunity to convert that potentially directly into actionable code, executable code. And so I think that we're seeing this massive shift around what are the different phases of AI and machine learning. And we're just at the cusp of seeing some tremendous breakthrough that's going to have a direct impact on the energy industry, the industrial category, and just overall.
So Peter, let's perhaps back up a little bit for some of our listeners that might not be domain experts here.
Yep.
Pattern matching is fairly obvious to most of us.
Yep.
It fits a matrix or it doesn't.
Yep.
But talk to us about how AI or even the Kelvin approach to creating intelligence that's beyond that circumscribed set of patterns.
Yep. Well, I think what we see is an ability to find patterns across very large data sets that historically may have been siloed. So the first challenge that many of us have is we have information that may exist in one database, and then the ability to sort of bring it together with other databases can be quite challenging. And that may be beyond the capability of the normal day-to-day user. So first, it's really a matter of getting access to the information. And then the next piece is it good enough quality? Is it good enough information that can be used? And so there's a whole process for making sure that just the historical data is usable. But then the next piece is, how do we bring it together? How do we actually look for potentially new patterns that may not have been seen before? Because again, we may not have been able to look at that data in a consolidated way. And that's actually where I think a lot of the tools in terms of being able to do more sophisticated pattern matching come to bear. So if you can sort of have a general idea as an engineer of what you're looking for, and you can describe that into the system, then what happens is you have the ability through these tools to be able to go find that pattern across maybe large data sets that you weren't able to access before. So it really it opens up a whole new area to explore, where there may be new patterns to be able to understand and use to be able to make better decisions, which at the core is like, what do we care about? Like, we want to make better decisions on a day-to-day basis. We want to empower our engineers and operators to do that, because when they do, then they drive better impact and results.
Well, I'm intrigued by that. By one thing you said is, how do you look for patterns that you've never looked for before? Well, how do you know what patterns to look for if you might not be cognizant of those? And one part of ChatGPT that's fascinating to me is if you just ask it to contrast X versus Y about some things that are not related, you might get something that's astounding and gives you a perspective that you never would have thought of.
Yep.
However, that's trusting a serendipitous approach to creating intelligence about something. How do you move from that serendipitous approach to something that's more structured and more of a systems engineering kind of approach?
Yeah, I think a lot of it is, we talk about the movement, the difference between sort of correlation and causation, right? It's one thing to be able to look at two different data sets and find where there may be correlation. The challenge is you don't know if there's any sort of causality in that either. You can't necessarily do that until you start to run experiments and decide, okay, if that new pattern then requires this sort of, or maybe creates a state change, then I'm able to start to make a causal inference between what it is that just took place and actually some sort of change in the system. And I think that's where we start to get more into the engineering side and the ability to say hey, this looks interesting. Now can we experiment with it? Now can we actually use it to see if it drives a better decision, a better outcome? So I think what's very important about this category is there's still a tremendous amount of human understanding that it resides within organizations that needs to be captured to be able to actually allow these ML and AI tools to be successful. Because the truth is, you can just throw a ton of data into these systems and you're going to find all sorts of correlations which may just be totally nonsensical, right? And that doesn't help you make a better decision. You need to actually be able to filter that down with some amount of human awareness to be able to then teach the system to look for things that the engineer would look for. And that's where you start to get better and better about it. And as I mentioned, you move from a world where you're teaching the system, you're giving it the rules to follow, and then you start to allow it to potentially discover new space, to be able to experiment a little bit with smaller changes or other relationships. And that's the piece where, we start to push into kind of potentially a new optima, and push sort of what your new Pareto could be. And that's where I care about, like, using these tools. Again, it's much more guided right now, and it will be guided for some period of time, because the human understanding piece is super important to making sure that it's efficient to get to those better decisions.
So if we do have an intuitive user interface to an industrial AI tool set, would it be, do you envision a scenario where you as the engineer or the operator ask a series of needs-based questions, a series of them, so that you get then either a compendium or you get some commonality across the answers, and it statistically you start looking at, well, this maybe is pointing us in the right direction.
Yeah, I think you can do it on a question basis. I think that constrains it to some degree. I also think in certain cases you may end up with almost an open text sort of approach where you're like, when I see this, when I see rate go above this and temperature go above that, then I take the following 3 steps, right? I take the following actions, right? There's a pattern recognition and workflow automation aspect to this, right? Which is when we think about the day-to-day for a lot of our users, they're trying to figure out how do I maintain the state of this system, or how do I actually get the state to change because I'm moving into a turndown, or I'm trying to increase the production of something. So a lot of what we look for are kind of what are the patterns that come together to then warrant some sort of a series of changes in workflow. And I do think that I don't think we're there yet, but I think we're getting to a point where that can be described in simpler and simpler ways that allows you to then create, in the way that we describe, we talk about a copilot, right? So our goal is to help enable that engineer to create this application that really does some of the things, that are maybe the more mundane tasks in their day to day. If you can make that super easy for the engineer to describe what they do and then create an application that does it for them, you've freed them up, right? You've done what we think is a critical, solve the critical problem today, which is saving engineering time, right? The finite resource right now that we see is the engineering time. There's just not enough of it, right? We can't hire them. We can't find them. We can't get them. There's just not enough. So what are we trying to do? Well, we want to be a force multiplier for the engineers, right? We want to give them a set of tools that allows them to be more successful, more effective, more impactful. And the easier we make the interface to sort of capture, like, hey, this is what I would do, the simpler it is for us to then prove, hey, this approach is better than that approach, and we can use it more often. We can scale it now more broadly across the system. And now all of a sudden you're getting some really interesting sort of expansion opportunities where you've taken potentially your best engineer on their best day, right, which is what we strive to find, and you've given them the ability to impact the broader system, right? And now we're talking about system level optimization and otherwise, but it has to come from there's usually one person, and we all know that person at these different organizations. We're like, man, if I could clone Sheila, we would be so much better, right? We'd be able to put Sheila all over the system. It would be amazing, right? Well, we don't have that cloning technology, but we do have the ability to capture a lot of the decision-making process that she may take, and therefore extend that so Sheila gets to work on these higher order problems.
So that's fascinating. I know the world isn't all blue sky for AI. So what are the obstacles and impediments to actually making this work in a real life scenario?
I think it starts with the information access. I touched on earlier, basically bad data, bad decision, right? Good data, good decision, right? And so I think part of it is like what information is available to you to be able to then make the best decision possible. And it starts there. I think the next challenge is frankly one of trust and a little bit of change management, which is the folks who are operating these systems have been doing it oftentimes in one way for a long time. And for the most part, it works fine, right? So there has to be a comfort with a new approach to be able to actually adopt it. You actually have to, I would say, trust but verify, around what are the different things that maybe this copilot is doing. Is it doing things in a way that, is consistent with the way that you would do things? And if so, you start to build trust. And that's what we see is the trust aspect is a huge part of it, which means the idea of dropping in some sort of kind of black box system that you can't understand the logic, like that just doesn't work because people won't trust it. And in many ways, they'll find situations where they'll undermine it by highlighting what the corner case is and where it was wrong. And so if it's 95% right, that means it's 5% wrong. And if the highlight and the focus is on the 5%, that's a great way to destroy sort of any new interesting technology, is to fixate on like what's broken versus saying, yep, that 5%, these are how do we take that 5% and make it 3% and then make it 1%, right? And if you have that mindset, then you're in a position where it's very powerful. I think historically as well, it required a lot of sophistication to be able to create these models. Sort of, you think about like you take a bunch of data, you dump it into, figure it out, Python, you've got Jupyter notebooks, you've got Azure Studio, you got a whole bunch of tools out there to be able to spit out a model that might actually work. The challenge obviously though is it works in the cloud and it works with pristine data and it works in a fairly sort of Panglossian kind of situation, and that's just not reality, right? So we have to take that model and you have to kind of ruggedize it, and you have to get it ready to be in a position where like, the data stopped for some reason, or there's this other issue, we lost power, like just the realities of sort of the operating world. And many of these models are so brittle that they break, right? And so then it's like, oh gosh, well, we can't trust that system. And so building up the robustness of that is important as well. And I do think that there are some new ways in which these models are being created that is going to get faster and faster. And this is a little bit of kind of what's coming from an OpenAI perspective is you're going to be in a position where the speed to a little bit of information can yield a much more sophisticated model more quickly, and that's going to be that will be happening next month, right? There's a new version coming out, and so there's going to be like more acceleration on that point, and that's where the truth is the impact is bigger, I think, than many of us can conceive, right? Potentially, because we have not seen that sort of rapid acceleration in this space yet. And what will that lead to? It will lead to probably some situations where things don't go well, right? And we'll see what the the fallout is. Now, I don't think we're that close to Skynet, but I also recognize like that there's also going to be a very natural resistance for some people who look at, they refer back to their Terminator movies and they're like, oh yeah, that was bad. Like, I don't want Arnold coming after me. I don't want Arnold coming after my job, right? So, okay, but there's somewhere between sort of where we are today and Skynet that hopefully allows us to get to a better place.
Yeah. So Peter, let me ask. While I don't think a lot of it is that fear and doom that we gets inspired by some of those Hollywood movies, what about the legacy engineer that might be an advocate of the waterfall model that approaches a project in a very predictable approach where it's, okay, what's my concept of operations? What are my user needs? How do I refine my needs to requirements? That I write my spec and now I have test plans, making sure every need matches every requirement. Where does AI fit in that legacy historical approach to engineering?
I think it comes back to how simply can we capture the concepts that person holds dear, right? Which are, I have an understanding, I know how to articulate what the system is. I know how to be able to describe what my objective is. I have a series of steps that I'm going to take to hopefully achieve that objective and walk through that. I mean, you asked the question earlier about like, can you have a sort of a prompted set of questions to capture that? I think that is one approach. But the key is what we're trying to do is make sure that their knowledge and their understanding of that system is honored and respected and in many ways sort of codified, because they have usually figured out how this system works and how to run it as well as possible through a series of iterations. Like, we talk a lot about artificial intelligence. I think about organic intelligence. Like that person has been running a system and trying to make improvements and getting it better and better and better over time. That needs to be captured. That's part of the reason why, if you look at, for example, at Waymo, right? There's a reason why we have people sitting behind the wheel driving cars and then a whole bunch of software capturing like all of the things that they do. It's similar in my mind. It's like that driver has learned how to drive over hopefully 10, 15 years and is now behind the wheel. We are learning from how that human and that organic intelligence in that system is working. And then we're understanding, okay, how do we look for those patterns and how do we apply different sort of artificial intelligence to capture that? And so I think it's a matter, and this kind of gets back to what I was saying earlier around simplifying the interface, making it easier for that person to describe it in what they do in a way that is accessible and it's not hard. Like if you go ask that person to go build a low code system or otherwise, that's going to be challenging. You ask them to do it in Python, forget about it, right? So what we talk a lot about is like, hey, we need one engineer, one process, one spreadsheet, and one problem. You give us that, like we'll get you a copilot. And the spreadsheet's the probably one of the key things there, which is like what's in there, because as we know, a lot of these systems are still run on Excel, right? And so there's a series of analyses and thoughts and otherwise. But the challenge of spreadsheets is they're fundamentally siloed, right? Like it's like, here's my Excel spreadsheet and it's mine, and I downloaded it and it's awesome. And as a person who has built a lot of Excel models, I can tell you the last thing that I want is somebody in there mucking about and changing my formatting and doing this and that. So it's like that becomes very proprietary, which runs counter to, hey, how do we make better collective decisions and how do we share knowledge? It's like, well, first we got to think about how do we get a spreadsheet into a format that actually is usable across a broader part of the organization. And I look at those and I'm like, oh yeah, great. How do we, if we can take a spreadsheet and convert it into some sort of code that's actionable, well, great. Now we can start to prove how good are those recommendations that spreadsheet is making. It really require a person to making the change. Like how do we make that? How do we go from an open loop approach, which is where a lot of these sort of advisory systems are, to much more of a closed loop approach? Because it's at that point in time that you actually have the ability to really learn. Okay, I can make a decision in a closed loop environment and measure impact and then learn from that. And I can make smaller, rather than broad, big changes, I can make smaller incremental changes and see what the response in the system is. And that's the piece that I get really excited about, because I'm like, yeah, we can have like lots of micro changes that we're learning from, and again, trying to push into potentially a new optimal state.
That's great. You've actually moved into what is typically my next question, which is how do we get over some of these obstacles? And perhaps what I think I heard was we've been good for a long time at stating the concept of operations formally.
Yep.
We've been in the last couple of decades pretty good at collecting certain amounts of data, but we haven't been very good at documenting, collecting, and using the embedded intelligence of the actual human engineer, the Sheila at work. Yeah. And that at some indefinite point in the future, Sheila's database will be in AI, so that in a perfect world, and maybe I'm too far in the future here, but I may be able at some point in the future to simply clearly state a concept of operations and have the optimal answer pop out.
That is a wonderful again, interesting Valhalla sort of moment, like, but has that sort of potential for sure.
So what are the, we talked about some of the technical obstacles. How about the business development obstacles? Where how do we overcome whatever resistance there may or may not be in the market for AI?
Yeah, we look at it as our most successful, instances have been where you have a highly motivated and empowered engineer. You've got somebody who's like, I know that we can do this better. And it starts with oftentimes their ideas being able to very quickly turn into something. And so there's two sort of key points sort of to unpack there. One is like, it does take leadership, right? We're talking about change in organizations. And as we know, organizations aren't super change oriented. Change is scary. So to make an organization change, it usually takes someone taking a leadership position and saying like, I know that this can be done and I believe in it and I've got an idea and how to make it happen. When we empower that person, when we empower the engineer, you start down the path, and that's super important. But the next thing is what I mentioned was speed. Like, it has to go fast. And this is where many of the interesting digital transformation ideas of the last 15 years have fallen by the wayside, because 6 months later, 9 months later, 6 years later, it's still not done, right? And I think part of that has been a function of the systems were very hard to change and people tried to tackle them with large teams. And we've really taken a different approach where it's much more about, let's empower the engineer, let's get one thing working, okay? And then let's get the sponsorship from their mid-level, because the thing for us, when we talk about change, it's really 3 tiers. There's an empowered engineer who's trying to make something happen. There's a mid-level manager who cares about the results and is looking to figure out how to improve their operation. And there's normally a C-level person who's saying, hey, I need this because I've got to achieve primarily probably one of 3 objectives. I got to increase production, and I'm struggling with that for some reason, supply chain issues and otherwise. 2, I've got a profitability objective. I need to do more with less people. I've got another constraint, et cetera. So that's second. And the third, and the one that's frankly driven a lot of interest in what we're doing of late, is also sustainability, and in particular, like net zero goal. So now you've got a board of said company who is told the CXO, go figure out net zero like 2050. Make it happen. We just told the street that it's going to happen. And this person's like, okay, what do I do, right? And how do you do that? Well, from our perspective and what we've seen is, if you can start to empower people in your organization to make these changes, you are a lot more successful, because then it feels like something that's happening organically. It feels like it's some growth from within that has also the opportunity to make that team feel good, like they've created something. So there's a lot of agency and positivity around that. And also, it doesn't get treated like a foreign agent, right? Where you can have amazing technology that comes in and it's going to wow everybody. And at first it looks good. And as soon as people start to poke on it, and then they realize, wait, this might be a threat to me, forget about it, right? Sabotage, change, like just all goes sideways. So what I've found is, if we can start with, again, we need sponsors kind of at 3 levels, but importantly, like, the impact is oftentimes coming from an engineer who's like, I can do this. And the beauty is, so many engineers are overwhelmed with ideas, right? They're like, I could do this, I could do that. I've got my Raspberry Pi over here, and I'm doing this side project over there. It's like ideas. The challenge is taking an idea and turning it into action, right? And really making that from that action true impact on the organization. That's where it gets a lot squishier, right? And harder to do, and there are lots of impediments. It's like, so that's where we come in. We're like, you have an idea, fantastic. Like, we've got a way to turn it into something that's actually going to drive a change. And then you can decide, hey, was that change enough to justify doing some more? Or, hey, we did it on small enough scale that it didn't work, so we're like, yeah, thanks for playing. We're on to the next thing, right? That's the piece that the empowerment side is super important. and this comes from our experience. I mean, at one point in time, we would come in with systems that say like, hey, you know what? Our stuff is probably better than some of the things that you have. And you can imagine how what kind of response we got. People, let me show you this data that shows that it's not. You're like, you missed the point. Back to like 95.5, right? 95% of the time it's better, right? So let's focus on taking that 5% and making that 5% to zero. So it's 100% better all the time. And that's the spirit that we want to come in with, which is like, but if that 95% idea that's having all this impact is an empowered engineer in your organization that's making a change, that's totally different, right? That's exciting, right?
Well, Peter, that's great, and I see your passion, and I'm getting enthused sitting here. Can you focus upon, you're clearly in your 3-level hierarchy of decision making. It starts with, as you said, the empowered engineer. That really sounds like the fulcrum. So what do you do to create and engender that internal champion who probably comes to you with just an ephemeral idea of how do you turn that ephemeral idea into, an emboldened champion?
Yeah, it's really with examples and a little bit of shepherding, right? So one of the things that we've done is we've been able to chart a path around, hey, Johnny was able to do the following. He took the spreadsheet, it was converted into this. It now is acting on the system over here. Like, do you have a spreadsheet that looks like this? Oh, you don't. Like, we have a situation right now where we have a guy who has a drawing. He's like, I've drawn out this. Here's my flow. Like, I've got it. It's all drawn out. And literally, we're like, awesome. Just like take photos and send that to us because we can convert that into a copilot. So it's more around like making it as easy as possible to sort of get the first copilot built, show what's possible. And a lot of what we've done is, again, provide tools to make that easy, but also provide the support. Like, hey, you're stuck on this. Like, got it. Like, come talk to one of our experts who can help, like, get you through that. And be in a position where, again, like, this is about, our goal is to lift these organizations to be able to give them more tools so that, we believe that the brains are out there. Like, when I think about a copilot, I'm like, what is it, right? It's a brain. Hey, this is the logic. These are the patterns. This is the stuff that I want to do in a body. And I'm like, we're the body. Like, we're going to be able to package that up, make it work on your systems, be able to deal with a lot of the mundane sort of, connections and otherwise that you don't want to have to deal with, right? You as the engineer want to be able to articulate, hey, this is what I want the application to be able to do. And I want it to be done. And the simpler you make that process and the faster that you take it, again, from idea to action, the more value you're going to create.
So, okay, Peter, so let's role play a little bit, perhaps. If I was an engineer facing a challenging problem at work, and I decide that the human copilots I have are not performing to fix my problem with me, right, I might go looking for a AI copilot. What do I need to deliver? How do I engage with an AI company, yours or anyone else? What do I just take pictures of my screen, or can I do it in a Word document, or what's the preferred way of documenting it?
Yeah, typically it is it's a series of questions. So there's a Word document around, like, again, we look for sort of problem statement and a description then of like, what is the system that you're operating? And one of the things that we've done is we've created a way to describe these systems at a component level up. So we look at how every different manufacturing system that we deal with starts with components, and then it builds up to machines, and then to assets, and then to systems. And so as soon as we understand what you're dealing with and what you're working with, we're able to then describe that. And we have a capability to sort of map that out. So we're like, okay, got it. Now we can see what you're working with. Let's describe what it is you're trying to do, right? And that's kind of the objective function, right? What are we trying to do here? We're trying to increase, efficiency here. We're trying to, what are the variables that we're working with? As long as that can be described, then it's a matter of like, okay, last question, what information do you have to work with, right? What data is out there? Are you data rich? You have tons of sensors, IoT'd up, lots of data, or are you like, I'm data poor, right? I have a trickle of information coming out of my antiquated SCADA system that I'm trying to figure out how do I parse into something. It's like, okay, we have to sort of be able to understand where you are on that spectrum. And based on that, and oftentimes not a lot of time, meaning hours, not days, we're able to come up with, hey, here's the first version of the Copilot, right? And once we've done it side by side with you, what we find is folks are like, oh, I got this. Like, I can go build my own, right? And then it's a matter. So we have some customers who, they're churning Copilots out completely independently of any sort of shepherding on our behalf, right? And that's kind of like, now you've got an empowered organization. Now you've got a real commitment to saying, yes, we have some great engineers who are able to articulate what these objectives are, turn them into Copilots, and now they're off and running and they're getting tremendous value out of this system.
Wow. In a first step in trust building, can you talk a little bit about the industries and applications that you've impacted?
Yeah, for sure. So I'll give you more of a traditional oil and gas example as one, where we developed a Copilot actually in Australia in the progressive cavity pump space. And in this instance, there's again, very talented engineer with an idea around how to capture some information about not only how the individual well was behaving, but actually on a system level, what was happening in terms of what was happening under the ground, what were the pressures in the reservoir, and some other information that makes sense. Like, these things are going to start to relate together. And based on that, was able to build an interesting model. And again, back to the model is the brain. We became the body to package that up and turn it into something that actually could take action. And what we recognized was to get adoption and to get understanding and buy-in and eventually really trust from the engineers, we just had to show them what the recommendations were, right? Which is like, speed change here, turn this down. And so the first phase of the implementation was a series of recommendations that they were popping up. So every, and this it depends on the industry, right? But in this case, you could make a series of recommendations every day, and they could either say accept or deny, accept. And what's really interesting about that is you also learn, is the engineer making the right decision? Because you can be like, well, we made a recommendation, but you didn't take it, and actually that underperformed. So now we're learning, right? So this is the important part. So what's interesting about it is over time, it was, accept, deny, accept. And then the next week, more accepts, and then the next week more accepts, and then finally, it's at 99%, accuracy in terms of these are recommendations that are accepted or are consistent with it. So what you find is, as you move to more and more high levels of acceptance, your trust is growing, right? And you're seeing how people are learning as well about, okay, maybe I would have done this a little bit differently, right? Maybe I will change a little bit and evolve my thinking around some of the decisions. That's an important part of this too. So we do it in that context around sort of a recommendation that moves, because then you're an open loop, right? You still are having those acceptances, but then you can switch into closed loop. So that's one example. Another one was we had a series of different, think about sort of a network of pumps that are working together that were all pushing fluid into a compression system. And one of the insights was that when we had we had too much pressure from two different pumps basically kind of arriving at the same time, you would have this disruption that would lead to a pressure spike, and it forced you to take a bunch of actions around that were both expensive in terms of the cost of engineering time, but also in terms of some other like production and environmental impact. And the insight was, wait a second, if we scheduled these, if we had awareness around the relative pressures and other arrival times, could we do it? And we're like, yeah, that's a classic queuing problem, right? So like we know where the math is, we understand how to like build this out. And that's an example of the results were so spectacular. We went from like huge variance in terms of production and ups and downs and all this other stuff. And all of a sudden, like the system goes in and it basically just flatlines, right? Meaning we're like step function change in terms of its production gain and stability. And when engineers say that, they're like, hey, I can't deny, right? They're like, that is a profound impact on results, right? So we see examples like that quite a bit. And then more recently on the manufacturing side, one of the things that we've been really focused on is how can we make sure that the process is running efficiently. And this is where I touched on some of the component level pieces, which is, historically, a lot of the asset health information is kind of siloed over here, and then process information may be over here, and you've got like disparate data sets. And one of our recognitions was if you were able to understand how efficiently these individual components are working, you can actually connect that to an energy utilization number, et cetera. So now we're talking about energy efficiency gains and potentially copilots that can help drive those types of outcomes where it's like, yeah, maybe we don't need to run it full tilt all the time. Maybe we run it at 80% here, particularly if I'm also taking into account variance in my energy prices. So all of a sudden we're starting to get to, again, what is the objective function? In this case, we now have some of our manufacturing customers are saying, yeah, like last year was tough, right? We had to shut down plants in Europe because of the spikes in our energy pricing. Like, what can we do in 23 to make ourselves more efficient? Just in terms of that, there's a cost side to that. So there's a very real profitability component, but there's also then the ability to run this more efficiently such that maybe you're getting closer to your net zero goal, right? And so it's like, those are the types of examples where, as you're bringing this information together, as you're empowering these engineers to start to solve these problems maybe differently, you can have impact potentially. Again, what are those three objectives, right? It's production, profitability, and sustainability. And we are finding that in certain instances, you can get the trifecta, right? You can produce more, you can be more profitable, and you can achieve your sustainability goals. And like when that happens, that's high fives all around.
That's been a great detailed conversation. Let's pivot to what do you see for the future, near term and perhaps longer term?
Yeah, I mean, I, like many people, are really appreciating the fact that there's a lot more focus on ways that we can be more efficient, right? And so I believe that is driving more interesting use of technology, and that's energy efficiency, but it's also like efficiency with our time, and how are we getting really the most out of our people? And I think that trend, again, it continues. The second piece is that there are only going to be more interesting sources of information. So I believe fundamentally that we will see, we haven't really touched on IoT, but for us, IoT is that's more feedstock, right? That's more information to help me make a better decision, right? Better sensors, better capabilities to measure the actual system itself. And we are Kelvin because Lord Kelvin used to say, to measure is to know. Okay, so we care a lot about how are we measuring what's really going on in that system, because the better that I can measure it, the better that I can manage it, right? The more that I can actually run the system very efficiently. And that's where I start to see the next phase of really some interesting sort of AI tools, right, that are coming. And that's what's going to be the probably the most impact in this industry is we're going to see more of those AI, capabilities creeping in to various parts of the organization. It's not necessarily going to be like big bang, I'm going to Skynet your system, overnight and everything is going to run perfectly. I actually think it's going to end up sort of seeping into smaller parts of it, such that folks are going to get more comfortable with better software tools that drive real impact in their operations, maybe not even knowing that there's AI or something under the table or under the hood that's actually driving a lot of that stuff. I I think that that's where you're going to see more acceptance, as opposed to it coming in with a much bigger initiative that's frankly more scary for a lot of folks.
Mm-hmm. Sure. No, your talk has me convinced that this granular copilot, or very granular copilot incremental approach is less scary and perhaps more productive in the end.
We think so. Like, again, we look at it around a little bit more of almost like a biological model, right? Where you're like, I need cellular growth. I need small pieces that are coming together that are driving better and better, more and more change, right? And that's the sort of thing that when you demonstrate it and people are comfortable with it, it changes a lot more comfortable at that point. You're a lot more accepting of it than, oh gosh, like this is some huge shift. It's like, no, it can be way more incremental. And unfortunately, like it just hasn't been, I'm not sure the technology was there. And I definitely don't believe that it was sold that way by a lot of the big vendors. You look at the traditional controls folks, right? That's not what they were selling. They were selling like big, huge implementation, switch it all over, 50 million, 100 millions, it's like, it doesn't have to be that way. I'm still a big Andreessen sort of software is eating the world, and software eats in small bites, right? So like we're seeing these small bites of change that are starting to happen. And this is, again, why it comes back to, if you empower engineers, you give them better tools to get their job done, you save them time, you're going to be able to positively impact their day to day. And that's how you get adoption. That's a lot easier than like having them sit through another 8-hour change management, meeting with a bunch of consultants who they despise, right? Like it's like, let's give them tools to show that what they can do, as opposed to forcing them to be in a position where they're like, yeah, this sucks. This is wasting my time. I don't want to do it.
No, and that approach, from my perspective, allows the trust curve to be on a geometric or maybe even an exponential curve, rather than a simple on-off once a year or once every 5 years.
Totally. Yeah, I think that's right. It has that potential. And the acceptance of this stuff is one thing. And then it's a question of, seeing how it works. And I don't, to be clear, like, I don't believe that AI is some panacea. I don't think that it solves every problem and is anywhere near perfection. One of my undergraduate professors writes basically every week around all of the reasons why AI doesn't work. And I read that, with an understanding that there is a lot of truth in it. We have to balance, again, it is an integration of human understanding and artificial intelligence. Like, it's not just the AI that's going to win, right? So how do we do that? How do we make it something that's more palatable? Those are the questions that we need to be asking. And then frankly, we need to try. That's the other piece. It's like, you actually have to have the confidence to try these things and be willing in certain cases for it to fail, but hopefully fail small, learn fast, and then apply on, with the next tool.
That's great. Well, Peter, we're nearing the end of our time together. Do you have any last words for our audience today?
Embrace the change. Like, there's a lot of really interesting new ways to be able to find problems, fix problems, and do it faster than ever before. And we want to be one of the tools that, that the folks who are listening are trying. And when we do that, and when we empower engineers, we have the ability to have a tremendous impact on the industries that we're touching. And I think more broadly in terms of some of the big goals that we have to make things better in this world.
Well, Peter, it's been great having you as a guest. My last request is, I know some of our listeners will want to reach out to yourself and Kelvin AI. Yep. Can you share some of your contact information?
Absolutely. So Kelvin.ai is the website, and then for different types of direct email, you can reach us at peter.harding@kelvin.ai.
That's great. Well, again, I've been thrilled today to have a fascinating conversation with Peter Harding, founder and CEO of Kelvin.ai. Thank you again, Peter, for joining us today. And we look forward to seeing our audience again on another episode of the Smart City Podcast. Thank you again, everyone.
Thanks, Jim. Appreciate it.
Our pleasure.
Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.